So, the grand finale of our thesis presentations for the class of 2015. Next up, 6 students will present a team project they worked on with the design firm IDEO for social impact in Ethiopia.
Okay, thank you. All right, so my name is Jonathan Tacky, and today we're going to be presenting the ZEMENAWI project. And I'm joined by my teammates here, Zach Carlins, Daniela Garzone, Seth Lang, and Ab Mortabito, and Nalat Yulong. So before we get started here, we want to give you an overview of the presentation. So as I mentioned, it is a team project, so it's going to be a little bit longer. We're going to try to do our best to keep it to about 40 minutes so you guys don't fall asleep. So, in the beginning of this project, back in the spring, we started out by prototyping a lot of things here in Chicago. And in the summer, we actually took a trip to Ethiopia. But for the purposes of this presentation, we're going to focus on the fall when we came back from our trip, where we did a lot more of the engineering and design refinements, which was mine and Zach's focus, and then the development of the business model and the implementation strategy, which Daniela and Nalat, Adam, and Seth focused on. And of course, this is our thesis project, but the project actually came from IDEO, and so we've had a lot of continued support and mentorship from them, which has been really great. So to give you the background context of what we did in the spring and the summer, we want to play you a video. It's about 6 minutes long, and here we go.
Good. Stay with this one pick. No, you stay with that. Yes. Yes.
Teff is the world's smallest cereal grain. It's an indigenous crop to Ethiopia, and it serves as the country's main ingredient in their staple bread, injera. Recently, Ethiopia's 6 million teff farmers have been struggling to meet the needs of the country's growing population. To counteract this, the ATA, or the Ethiopian Agricultural Transformation Agency, has introduced row planting. Row planting allows for higher yields and uses less seed than traditional broadcasting methods.
It just all falls flat. I don't know if
In 2012, ATA partnered with IDEO.org to design a mechanical row planter to help the country's smallholder farmers. Their design is able to dispense both seed and fertilizer 4 rows at a time. This year, the project was transferred to IDEO Chicago, where it was adopted by our team of Northwestern University master's students.
With the guidance of IDEO designers, we jumped right into the project by starting on the refinements to the existing planter. There were 6 key features that needed to be designed, and for each one we went through multiple iterations. One major challenge of the Ethiopian terrain that was discovered by the IDEO.org team is that the wheels collect a large amount of mud, effectively making the planter impossible to pull.
Wow.
The previous team learned from farmers that burlap does a very good job of shedding the mud and is readily available, so our team redesigned the wheels to hold the strips of burlap. To simulate how the new wheels would behave in an Ethiopian vertisol, we built a test bed here in Chicago. We were able to see that we were on the right track, but we still need to test the wheels in real conditions with farmers on actual Ethiopian soil.
See the mud starting to come onto the wheel.
So we packed our bags with parts, tools, and everything else that we would need to retrofit the rest of the planters and headed to Ethiopia.
The first goal of the 3-week trip was to observe the planter in its true environment to learn how we might improve its mechanics and usability. Initially, we felt a little limited creatively. We were used to prototyping in a shop with saws, mills, 3D printers, and all of that.
Like this one? Yeah, there's definitely very.
So when the burlap didn't shed the mud as well as we had hoped, we freaked out a little bit.
Like match the speed, but yeah, because all.
But with IDEO veterans at our side, we stayed up late brainstorming solutions. The next day, we found materials in local markets and a crude shop that we could use. Eventually, we were able to successfully test a prototype of a mud scraper.
So let's take one more pass here.
As we spent more time with farmers, we came to appreciate the fact that they can't afford a complex machine and don't have the experience to maintain one. So with just a stick, some zip ties, and duct tape, we realized that the handlebar itself could just act as a natural mud scraper, giving us a simple feature for essentially no added cost.
Slice right up.
traveled to multiple regions in Ethiopia during this prime rainy season to plant teff in controlled governmental plots. The main goal was to compare the physical performance of the planter and also the yield against these other traditional methods. So at each location, we demonstrated how to use the planter to regional officials.
Pulling these down, unlocking.
These regional officials are our connections between the ATA and the farmers, so it's very important to get their opinions and buy-in. We also drove out to the farmers' fields with the planter, and then we asked them to interact with the planter in context. Overall, we got really positive feedbacks. They liked that they could row plant faster with less manpower while also expecting higher yield. These interviews and observation really helped us envision how the planter would fit into their lives. In the field, we saw which aspects were most important to design around. We learned that while it might not be perfect from an agri-science perspective, we must make the planter cheap, light, simple, and robust, also keeping design for manufacturing in mind.
And you did 3, 4, 5 here?
Yes. When we're working in the studio, we can sometimes follow through with designs that are unfit for the actual environment. Testing the planter in the field refocuses our goals around what is realistic, and it aligns our future design to something that will serve those using it. Ultimately, this is a device that is meant to make the lives of farmers easier and more productive. We're excited to have this opportunity to design a device that could impact the lives of millions of Ethiopians.
All right, so that gave you kind of a background of what we've been doing from the spring up until when we came back from the trip. So now we want to give you an overview of how the machine actually works. There are 3 main components to it. There are the hoppers, and these contain both seed and fertilizer. There are the metering units. And then finally, there are the wheels. So let's take a single metering unit with the hoppers on top of it. And let's cut a section through there to see what it looks like on the inside. So here you can see this highlighted pink area. Those are what we like to call the fertilizer and seed drums. And you can see that they have cavities in them. Also, in purple, you can see highlighted a shaft. This shaft is directly connected to the wheels. So when a farmer is pulling the planter, that shaft spins, which in turn spins those fertilizer and seed drums. And so gravity pulls the seed and fertilizer down into the metering unit. And then, when the shaft starts spinning, it turns that drum, which deposits the seed and fertilizer onto the ground. And that's pretty much it. So when we came back from Ethiopia, we all kind of focused on different areas. And my focus in particular was redesigning the seed and fertilizer hoppers. Now, more so with the fertilizer hoppers, because the seed hoppers are currently simply cut pieces of tubing, and they're very cheap, and we didn't have that many problems with them. But the fertilizer hoppers we had a lot more problems with when we were testing in Ethiopia. So we came up with a list of criteria for the new design. And those are that it must not collect excessive mud from the wheels, it must be easy to handle, it must be easy to put on and take off of the planter, it must be easy to fill with seed and fertilizer, and it must not spill seed and fertilizer when you remove it from the planter. So we start off with the metering unit from the side view, and it's got this kind of boxy looking fertilizer hopper on top of it. Now the seed tube contains 150 grams capacity and a dispense rate of 3.5 kilograms per hectare, but as I mentioned before, we're not really adjusting the seed tube as much with this design. What we want to focus on is the fertilizer hopper, which has a 5 kilogram capacity and a 100 kilogram per hectare dispense rate. And for reference, a hectare is basically 100 by 100 meter plot of land. So the first thing that we wanted to do is that we noticed in Ethiopia there was a lot of mud collecting on the rim of the wheel that would get onto the hoppers. And so we wanted to bring the hopper within the circumference of the wheels. So we basically just chopped off the top of it. Now at this point, there's a lot of, when you're getting to the end of the fertilizer inside of the hopper, there's a lot that can be wasted because of the flat bottom. So what we wanted to do now was angle the walls on the bottom so that way everything is funneled directly into the metering unit and nothing is wasted. So now we're kind of chopping off bits, but we want to maintain the volume of the old design. And so we extended the walls to the fore and after the machine to keep that volume. Now, as I mentioned before, this needs to be easy for farmers to handle. They often have to walk very long distances, especially if this thing's filled with fertilizer. And so we added a handle on top of there. And now we have to incorporate that seed tube somehow. And so we put a cut through the middle of the fertilizer hopper, and the seed tube can slide right in there, and the fertilizer hopper wraps around it. So this is all well and good, but we need a way to support this thing, because when it's filled with fertilizer, it gets pretty heavy. So we added another part, and this not only supports the whole design, but it actually locks everything into place. And so from there, went to CAD and got this final design. It has a wide opening, so it's easy to fill. There are valve mechanisms in the bottoms of both the seed and fertilizer hoppers, so that way when you remove them, they don't spill anything out. It has a new capacity of 5.8 kilograms, which is about a 16% increase from the old fertilizer hoppers. The fertilizer hopper itself can be blow molded with high-density polyethylene using a injection molded preform, and the frame part, which replaces a previous steel frame, is a lot easier to use and can be easily injection molded. And now Zach is going to talk about the wheel design. So transfer this.
Yeah. All right. Can you guys hear me? Cool. Yeah, so as John mentioned, my focus coming back from the trip was on redesigning the wheels for manufacturing. And you can see here, this was the old wheel that we brought with us on the trip to Ethiopia. And we're really excited to get out there in the field and start testing it. When we got there, it was working pretty well. It was holding the burlap in place. We had these new straps that come around the wheel and hold the burlap. It was doing a good job of that, and the farmers we interviewed said it was easy to use and they liked it. So everything was just swell. But then we kept pulling, and we started to realize we might have underestimated the forces that are exerted on the wheel during normal use, and then the wheel broke. And so we freaked out a little bit and wanted to kind of figure out what exactly was going on here. So we inspected the wheel, and you can see that it actually fractured at the hub on the top there. The plastic just broke, and we wanted to find out what exactly had caused this. And it turned out the reason was from turning the planter at the end of a row. And John's going to come up here and do a little demo with me here with the actual planter that we have. So you can see as you pull it through the field, it actually creates marks in the mud. And that's what you'll use to align the next row when you turn around. So he'll look for the marks. You can see them here in the picture, aligned here. And then when he comes back down, he wants to plant the seed in even rows. So he'll use that to line up the next row. And we can also see him in Ethiopia doing the same thing. But so when he gets to the end of the row, the best way to find that mark and line up straight with it is to just completely pivot on one wheel, the internal one there, which is fine in some cases. But sometimes you have thick mud, and if you try to pivot it on the wheel when it's stuck in mud, it's going to put a large torque on the wheel itself, because the handlebar is essentially acting as a large moment arm, giving you a lot of leverage to induce that torque on the hub of the wheel. And so it was clear that we needed to make some changes here, and we had kind of made the most we could out of these vacuum-formed prototype wheels, and it was time to move forward into the next phase of the process and actually design something to be manufactured. And so I decided to tackle that challenge with the following general design objectives of increasing the robustness, decreasing cost, continuing to minimize mud collection, and finally decreasing the spacing between the wheels, which is something I'll explain a little bit later. So it was decided that the best manufacturing process for these wheels is structural foam molding. Structural foam molding is similar to injection molding in a lot of ways, but has some small differences. For those of you who don't know, with injection molding, you have a mold, and you have molten plastic that is pushed into the mold under high pressure, and then it solidifies, and you remove the mold, and then you have your part. With structural foam molding, instead, you have a chemical reaction that takes place where the plastic expands into the mold, and this is done at low pressure. So this results in a few different things. One, you have, instead of just a solid part throughout, you have a very solid skin on the outside here, and then a less dense kind of foam core on the interior. And that's good because it provides the densest and most material in the places where it's structurally most important. So you end up having a part with a higher strength to weight ratio than you otherwise would, which is good for this application, and then you end up using less material, saving cost, all of that. Some other benefits are that it has high impact resistance, and because it's done at low pressure as opposed to high pressure with injection molding, you can have larger parts and still have good dimensional accuracy. It's also an easy surface to clean, good for mud, and pretty impervious to the elements, which is also good for this application. One of the major downsides, and the reason why you don't see it out in the real world too much, is that the surface finish isn't that aesthetic. You can see it here in mostly industrial applications and the children's slide. But for this application, the aesthetic isn't as important as just getting the robustness and decreasing the cost. So that's what we're really going for with this. So with that in mind, I did a lot of research on the process itself. What are the different constraints? How do you design parts for it? And then did a lot of sketching in CAD and iterating on that. And then finally ended up with this design here. And this would be made out of HDPE, which is a plastic, high-density polyethylene. And that material was chosen because it's very cheap and yet still fairly robust. And with current market prices, with just the material cost alone, that would result in the wheel costing about $5 or $6, which is very good for this product. So I'm going to go into a few different features of the wheel itself and explain the design that went into that. So we talked about this loading condition before. So I wanted to make sure that the wheel was definitely robust enough to handle that. So I looked at modeling that in SolidWorks using FEA analysis, seeing that a human, we calculated they could put about 30 pounds of force sideways, and then looking at what kind of forces or torque does that translate into on the hub of the wheel, and how is that stress distributed throughout the wheel. And you can see here on the final wheel design that the highest stress concentration is in this red part here, but even that is actually 3 times lower than what it would take to cause a failure in the wheel. So that ratio is known as a factor of safety, and a factor of safety of 3 is good. All right, the next problem that I tackled with the wheels here is the spacing between the wheels that I mentioned before. So agroscience recommends that the rows of teff be spaced 20 centimeters apart, and that's exactly what our planter does here. You can see that even in the old version of the planter, they're 20 centimeters apart. But because we're using the wheel marks to align the next row, that means that the spacing in between the wheel center and the adjacent metering unit is also important. So if you imagine coming down a row and then turning back for your next pass, the next row of seed would actually be 15 plus 15, 30 centimeters away from the previous one, and we'd prefer that to be 20 because over the course of a large field, that spacing adds up and decreases the efficiency of the planting, and also it's helpful for the ATA moving forward to get over some political hurdles to push this design through. So one of the benefits of using structural foam molding is that it allows us to play with the geometries a little bit more. If we had decided to blow mold this, it would be a similar form to the previous wheel where it's more hollow, whereas the structural foam molding is more of like a skeleton. So we have the hub of the wheel, the main face, and then the rim, and we can kind of move those independently of one another a little easier. And so we can do something like this here, where those can move in, and now the wheel center is inboard on the wheel a little bit. Now the only problem you can see with that is now it might intersect with the fertilizer hopper there, and that's why John and I worked together a lot, and why he brought the hoppers down so that it's compatible with this design. I also increased the radius of the wheels so that it could come out a little bit more, and then that brings you from that where we have the 15 on the edges, and now that's down to 10. And you can see how the fertilizer hoppers are kind of nested underneath the wheels, but still far enough away that you won't have significant mud collection. And speaking of mud, you guys saw in the video, this stuff is really sticky. And you take one step in there and you lift up what feels like 10 pounds of earth with you. It's pretty crazy, unlike anything we have here. So wanted to make sure that whatever new design I'm working on definitely can still handle that. And so the benefit, I talked about having the more skeletal design is that we can kind of move those parts around. But one downside is that now we have these sharp corners on the inside where you might see mud collecting where it wouldn't otherwise. So to solve that, we add in this mud shield here that kind of brings it up at an angle so the mud is more likely to slide off as opposed to collecting in those corners. And this mud shield on its own is just a very thin plastic. Could be made out of HDP as well, and it could be die cut from a shape like this. And because it's very thin, you can just fold it into that conical shape, and then it could be welded onto the wheel during manufacturing. And then the last feature of the wheel that I want to talk about is the strap system. So this is the one that we had before, and when we were in Ethiopia, it worked really well, like I said before. Very user-friendly, but I wanted to see if there was a way that we could reduce the cost of the feature, because we have these, you can see on the left here, this is how it's fastened to the wheel. We have an eye bolt, 2 washers, and a nut, and that's how the strap is fastened there. So I thought, how can we use the benefits of structural foam molding to integrate that into the design itself? And that's how I ended up with this here. And you can see a video of me using it here, where during assembly, the strap could be pushed through this larger hole and then kind of press fit downward and then rotated into a position where it's really, really tight in there and pretty much stuck. And that would be the side that's permanently attached. And then during normal use, when the farmer gets it, they can pull it over like they did before and lock it into place. So just getting rid of a few nuts and washers and a bolt doesn't seem like that big of a deal, but there's actually 8 of those per wheel and then 16 per planter because there's 2 wheels. And in a project like this, cost savings are huge, so that'll definitely help reduce the overall cost of the planter. And so now you can see the old version and then the new one with 2 major features redesigned that John and I have worked on. And so now the project is ready to move into the next phase, testing these features and finalizing the design to move forward into manufacturing and then implementation. And to talk about the implementation and the strategy moving forward, Danielle is going to come up here.
So as Zach and John were working on the mechanical design, ZEMENAWI, Adam, and I were set off to develop a rollout strategy for the planner. So having a beautiful machine is the first step. But if we don't come up with a robust implementation strategy to really figure out how to integrate this into the lives of the Ethiopians, the product would fail in the market. So this involves understanding the people that we're designing this for, their culture, and the society that they live in, and how this planter fits into their lives. We set out to explore this with this question in mind. How might we get 2 million teff farmers to adopt the row planter by 2020? So starting with the research aspect, we wanted to understand the people and their culture. I'm going to illustrate the life of a farmer for you. This is Sintayo. He's a 30-year-old farmer who lives in Wiliso, which is a rural village in northern Ethiopia. He grew up there farming with his father, mother, and 4 brothers. 5 years ago, he got married, and he built a house to start a life of his own with his wife. His house came with a small plot of land for farming, and he's really close with all his neighbors. They're almost like family to him. He watches their kids, they watch his kids, and make sure that everyone stays out of trouble. They share oxen to get work done on the field. And after a long day of work, they have dinner together at each other's houses. Their level of trust is so high that they might even pitch in together to buy communal purchases such as fertilizer for the planting season, so to buy in bulk. Now Sintayo's family is growing, which means more help on the field, but also more mouths to feed. He decided to rent a plot of land about a mile away from his home. Altogether now he has a hectare of farming land, which is about the equivalent of 2 football fields. This allows him to produce about 800 kilograms of teff during a planting season, 80% of which he keeps for himself and his family and his livestock, and 20% of which he sells. Altogether, with teff and all the other crops that he sells throughout the year, he only makes about $350 a year. Last year, a development agent came to him while he was farming on the field, and a development agent is part of a government organization that helps encourage different agricultural methods to farmers. So they came in and they introduced this row planting method to him, which is essentially putting seed in a plastic bottle. They walk down a straight line to enable them to plant teff in rows. He wanted to try out this method to increase his yield. And as you can see here, it was very successful. And he saw a noticeable quality in his teff yield and in the quality of the grain. However, since his crops are his livelihood, he only wanted to plant half his field with the new method and half with the original broadcasting method that he grew up with. This is his field with the broadcasting method. And as you can see, the yield is not as great as in the row planting method. He's excited about this advance in the agri-science research, and he would like to try it some more. This year, however, the rainy season came late, and this allowed a very short window of time to plant the actual teff. So him and his neighbors are working really hard, preparing the land to get it ready for the teff planting. But when it comes to the proper soil condition to actually plant, they're not going to have that much time. So he said he's going to resort to the traditional broadcasting method. The development agency has presented them with other technological advances to help improve the yield of teff, including threshers for the harvesting process. He's really open to this change in teff, in farming technology in general, and he really welcomes this shift if it's going to help move Ethiopia in the right direction. So the story of Sintayu is based off of the lives of the many farmers that we met and interviewed while we were in Ethiopia. From them we learned about the life of a farmer and what their values are. And by understanding what's important to them, we're able to focus on delivering a product that's going to appeal both to their physical and to their cognitive needs. So starting with their basic physical needs, they want to produce more teff. This is going to ensure food security for them. Furthermore, if they have higher yield, they're going to only need the same amount that they had before to sustain their families, and they're able to sell the additional amount to make more money. Moving into the cognitive aspects, they can improve their community by improving the farming in their community and really rising the level of agriculture there. And finally, by pioneering new farming technology, they're going to help move their country in the right direction and really move Ethiopia forward. So using these values that the farmers have, we set out to explore different business models, which Steph is going to go into.
Awesome. Okay. Okay. Everyone can hear me? We're good? Wonderful. So based on what Daniela gave us, and we now have a really good foundation of what the Ethiopian farmer is like and kind of the ecosystem that we have to build this new technology into. We know that they want it, but how can we implement it in a way that is easiest for them to adapt without changing much cultural significant issues? So to do this, we really need to start by analyzing how could the planter fit into the lives of Ethiopian farmers. And to do that, we need to understand, beyond just them using the planter to plant, what are all the touch points that they encounter throughout the entire lifespan of the planter and their interaction with it. So everything from awareness through planting and then eventually to maintenance and storage have to be evaluated and really considered as touch points when we're designing a business model for them. When we're doing this, there are key factors that each of these hinge on that we as designers have the ability to influence while we're developing these models. And while all of these are important, it was very quickly relevant to us that there's one that's significant that everything else is kind of pivoting on. And if we aren't able to satisfy that for Ethiopian farmers, then the likelihood of this project really being pushed through and advancing isn't going to happen. And in our case, that's cost and the element of purchase. As Danielle alluded to, these farmers are making $350 US a year. And at initial estimates, the planter is going to cost around $100 to manufacture, potentially more. So for an outright investment, asking farmers to invest a third to half of their income on a machine that they will use likely 2 weeks out of the entire year is kind of a stretch. So we really needed to understand what are potential business models that are a little creative that might help this get rolled out more quickly. And we did that by really digging into the case studies of various other social impact projects that have been rolled out through developing countries over time, as well as just generally the research that we did while we were in Ethiopia. And we came up with 3 distinct models. The first of these is the individual purchase. So I just mentioned, obviously, that the smallholder farmers are unlikely to be able to afford this. So this is geared more towards the medium holder farmer who has around 3 to 5 hectares of land, potentially employs labor to help plant the land, and has a lot more ground to obviously cover. But along with that, he's also making more money and has excess resources to invest in a planter such as this. And he will be able to more efficiently plant his larger plots. And while he's not using it, he has the ability to loan it out to those smallholder farmers such as Sintayu. And we will still hit that smallholder farmer target user that we're really going for. The next model is the collective purchase, also alluding to the information that we found while we were in Ethiopia of working together. This model is built around the idea of 4 to 6 smallholder farmers with a half hectare each coming together, pooling their resources, and buying a planter outright. Then they would have to share during the planting season, but it's a lot more affordable for them to invest in initially. And then the final model that we were exploring is really focused at the higher goal of Ethiopia in developing the economy beyond just growing teff. How do we actually expand the economy and develop new businesses? And that's through entrepreneurial rental. And this idea is built around an investor buying out maybe a fleet of planters, and then during the planting season they can travel throughout Ethiopia and rent out these planters to the smaller holder farmers at a fraction of the cost that they would need to actually invest in it. And so again, we're hitting that smallholder farmer that we're really looking to. So it's all well and good that eventually we'll get to the smallholder farmer and everything should be designed around that end user, but it's really critical to understand that there's a much larger ecosystem at play, and there are a lot of other people that are involved in trying to roll this out and have influence on it. So at various levels of relation with the smallholder farmers, you have their neighbors, people who also use the planters. We have other organizations, NGOs, people just agriculturally or involved in the agriculture ecosystem in Ethiopia. And at the highest level, we have the government and really trying to push that forward with our main partner, the Agricultural Transformation Agency. So we took those 3 models that I just showed you, and we wanted to make sure that we got the perspective of all of these different areas, or all these different stakeholders, to understand where they see value in those models and where they see disconnects. And so the first one is Johannes, who is actually, he grew up in Ethiopia and currently works in Chicago at the Community Association for Ethiopia, and has a really good understanding of the culture of Ethiopia that we could couple with our experience while over there. Leslie is someone that we actually met while in Ethiopia, and he works for 1 Acre Fund, which is an agriculturally focused NGO that is working on developing agriculture throughout countries like Ethiopia and other developing areas. And then finally, Anas, who is our main contact at the ATA and who we've been working on this project with significantly throughout the entire 9 months, has been really helpful and has the government perspective of what they're trying to achieve. So through these conversations and working with various other parties, we came out with 2 key insights moving forward. The first of these is the community mentality. Ethiopia is really built around the concept of working together to achieve an end goal. And it's really important that they plant together, they prep their fields together, they're harvesting together, and they're reaping everything together. So this idea of just working together in order to achieve that goal is already in place and ingrained in Ethiopia. And then it was also it became apparent to us fairly quickly that the leveraging of resources is very critical. So in developing countries, there's not a lot of infrastructure. And so it's important to use infrastructure that does exist. And the government and the ATAs especially have developed channels for information to be spread throughout Ethiopia agriculture. And so information along with the product and leveraging those resources of government really fed into choosing a model. And we were fairly quickly able to recognize that a collective purchase model is probably the most likely model to be rolled out and adopted fairly quickly. And there are several advantages to this. The first of which is a low barrier to entry financially. Like I explained earlier, it's a lot easier for them to give a smaller fraction of their income to invest in this. As I just alluded to, the utilizing of the pre-existing infrastructure that the government has already established in connections is critical. And then also working on that cultural norm of working together to accomplish the end goal is kind of what we're going for here. Obviously, these models are not ideal, and there's some disadvantages. So with this model, considerations that need to be addressed are the complex planting schedule. So teff can only be planted for about 2 weeks out of the year. So if 6 people are trying to do this, they'll have to have a fairly well-scheduled and understood distribution of how that's going to happen. Additionally, with maintenance, we have 6 people going in on a planter, so who actually owns it, who is responsible for it, who is going to maintain it, because this is a complex machine for them, and if it's not well maintained, it's not going to function appropriately. And then also financial responsibility and understanding the various levels of investment of farmers and recognizing what their access to the planter will be based on that. But luckily, with all of these and the research that we did, we're fairly confident that these can be easily overcome, and they have a good understanding of how they could work together to achieve them. So in zooming back out just a little bit, looking at the development of the planter, as John and Zach have done, and IDEO and ATA have been working together for almost 2 years at this point, we have a fairly developed product that we know is bringing good value to the farmers. It's increasing their yield. And on the opposite side, the implementation, our team has been working on the strategy for a few months now. And with this idea of a business model rolled out and understanding the connections, we're fairly confident that this is going to be successful. But there's some gap that needs to be bridged, and Adam is going to help us bridge it.
Hopefully, hopefully. Thank you. Just like a clip. Nice. All right. Cool. Can you guys hear me? Am I good? Oh, wow, yeah. Cool. All right. So the difference, the gap between development and implementation traditionally is understood to be marketing. Marketing can be defined in a different way as saying it's messaging to communicate value and belief secured through trust. So what we want to do in our marketing campaign is first and foremost get our value out there, and secondarily, we want to be able to build trust with our consumer in order to get this value to be believed by them and understood and accepted. Daniela kind of already walked you through this, so I won't belabor an explanation about the value that we're trying to connote here. But if you look at this pyramid, it actually tells you a story about how this planter is going to live in the life of a farmer. So you buy the planter, and you plant with a teff row planter in order to augment your teff production. This allows you to have more grain and eventually sell more of this. Here's where we stop and look at what it means to be in these physical areas of value. What we understood from Ethiopian farmers is that to understand and believe in a physical value, they need to see it with their own eyes. The trust is developed through their own experience. Moving forward, when you jump into the more cognitive aspects of the value, we see that community becomes a huge aspect. But first and foremost, we want to get out there that furthering the use of this planter allows for you to make your country proud, move your country forward, and be proud about your country. This type of a message, though, is something that doesn't get communicated very simply. It's not something that I can just state in a marketing message and be accepted. You need to trust the message that's being sent to you. This stuff is also not proven physically until 10 years down the road, when this planter has already lived and when Ethiopia has already moved forward. So how do you connote a message like this? And this is where our branding came in. We wanted to understand how we can go and brand our planter in Ethiopia. And this is difficult for students in America, in college here, to bridge that language barrier, the cultural barrier, and also just create images that are just as powerful for us as they are for the Ethiopian farmers. And here you see the brand image that we went with. You see pretty much drawing of our planter as well as ZEMENAWI, which was the tagline for our project and also was chosen by farmers in Ethiopia, which means modern in their native tongue. and then English words saying moving Ethiopia forward. The simplicity of the message allows for it to be changed into their language, and it's a comfortable amount of area for them to kind of move around in language-wise. And we weren't trying to really tell them what to say yet. What we noticed looking into kind of how TEF is planted, that in the schedule of the year, there are 2 TEF planting seasons. And so if we wanted to, first and foremost, get out there the physical value of our message and prove to them, we can do that during these planting seasons by doing on-field demonstrations. So what these on-field demonstrations look like is development agent, like Daniela was explaining earlier, goes to a field, starts talking to a community of farmers. He recruits them to go to a common plot somewhere out in that region where they are informed about the planter, taught about the agri-science, and let to use the planter on a plot that's specific to them. Later on, at the end of the planting season, when it's time for harvest, they'll come back to that demo field and they will harvest their specific plot, thus seeing with their own eyes that the yield is increased. At this point, we believe that trust will be connoted to them about you have now seen this, this growth. And so here, at the end of this, we give them a pin or some type of artifact to move away from this service from, so that they feel positive about the message that they're carrying out to their community, as well as showing them as the expert and saying, you are the owner of this or you are the expert, now go share it with your community. Moving forward though, we still want to get this cognitive message out there. We want to get the cognitive value communicated. And so that's going to happen in between the planting seasons through an aggressive brand awareness campaign and also some word of mouth communication. Brand awareness for us has 3 main tenets: product tagging, official partnerships, and a visual campaign. An official partnership is as simple as saying that the government is working with us. Not really that similar to the United States, but when the government tells you something in Ethiopia, it's understood to be true and understood to be a trustworthy statement. I don't know if I really trust our government telling me stuff, but that's ancillary. The second thing would be product tagging. So piggybacking on the trust of existing brands in Ethiopia, this water bottle here, Yes Water, is a very popular product in Ethiopia. They like the Samsung brand as well. And this is beer everywhere is the marketing kingpin. So just tagging our logo onto these types of brands will piggyback on the coattails of that brand image and that brand trust and allow us to kind of generate more of this trust as we move forward. Paramount, though, to this campaign is a visual campaign. So here you see kind of a shack out in Ethiopia and our symbol tagged on the side of this structure. So what we want to do is have people walk around and just see the symbol everywhere and understand that it's a ubiquitous thing in the country and kind of get it so virally out there that they start to almost, as a secondary meaning, see planter, ZEMENAWI, move Ethiopia forward. This is another example of visual campaign where we kind of put out those 4 images that I showed you earlier on the back of a van. And again, finally, this would be our marketing plan moving forward.
So overall, we've been working for the past 8 months on an engineering challenge. Where's the clicker? To improve the performance of the planter. And then on the strategy side, we're trying to find avenues that the planter would fit into the ecosystem. But as designers, we always have to zoom out away from the planter and reflect upon whether or not it fits the need in the first place. So we want to take a quick look at one of the FAQ questions frequently asked, which is a row planter the right solution? So let's take a perspective of the government who actually initiated this project, right? What is their goal? Similar to the farmer, they want to produce more teff. Why? Because they need to ensure food security and ultimately grow the economy. The GDP of Ethiopia is 42% dependent on agriculture. So agriculture really drives the development, and that's why the ATA is formed to begin with to kind of catalyze this kind of chain. And looking closer at producing more teff, the ATA itself has multiple initiatives that addresses the whole value chain of teff. This is a big value chain. So they have initiatives from improving seeds, mechanization, increasing market access, and even value-added products. With this, diving really deep into our research, we found that row planting, even though it's a small speck in the whole spectrum of this, 6 months, if not longer, cycle, if done right, it could really create a big impact. For example, based on a study, if you row plant, it takes about a day, right? And if you do it right using less seeds, you actually get higher yield, 1.7 times of the traditional method, compared to if you do proper harvesting using the mechanized thresher. Takes longer, and the effort pays off to about 1.1 times. So just in general, looking at this, we think row planting as a solution for producing more teff is definitely a smart place to address. But what are the mechanisms? The ZEMENAWI planter is not the only one. Danilo mentioned bottle planting, which is what started it all, and I'm sure there are a lot of innovations out there too. But what we know about our planter right now is that we know our strengths. We're good at increasing yield, distributing seeds and fertilizer uniformly, planting really efficiently with tight spacing like Zach mentioned, and also improving planting time by dropping seeds and fertilizer at the same time and 4 rows at a time. We know there are things that we can improve on and need to improve on, including durability, making it tougher and more robust, improving usability of it, and making it easier to transport around. Our biggest obstacles, though, are mud and money. Mud, because it has ground contact, a lot of features have to be designed to combat the mud itself. And as for money, for the farmer, buying the planter is like buying a car, and for us, there's a trade-off between cost and performance itself. Combining those obstacles that we know with the value propositions that we have learned over time, we ask ourselves, what other row planting tools might satisfy these requirements? So we did a quick little brainstorming. And on the scale from simple to advanced technology, we see our planter kind of hovering somewhere in the middle. And if simple technology means, putting seeds in bottles and walking, we're like, why not put 4 on a stick and walk as well? Or take the wheels off of the planter and walk. Irrigation would be nice, but infrastructure is the biggest issue. And maybe further down the road, a John Deere-like tractor could be a solution for Ethiopia, just like it is for America right now. And who knows, one day they might plant with a drone. But besides all these mechanisms, what are the non-mechanical tools? Training is a big one. Organization like One Acre Fund is already on the ground and doing that in Ethiopia. And with growing practice of row planting, a knowledge-sharing platform would be really good to share tools and techniques. Planning forecasting could really help with weather and market pricing. And even embedding metrics, almost like Fitbit for your farm, could really help improve the performance of planting itself. So overall, where we are at this point is that we think what is appropriate for Ethiopia right now at this time is a simple incremental technology that could live in an environment where water still needs to be hauled every day for use, and electricity is a luxury for them. And it's not just a one-step solution. It has to be a systemic approach to really increase teff production overall. So going forward, where we are now is refining the engineering design. The ATA is intending to do a mass demonstration for this coming season, and also trying to secure funding from the Ethiopia government. And then right after that, they're going to do manufacturing. And 2017, in the summer, that's when they hope to really launch the project. With our strategy studies, we would also recommend a parallel path for the ATA to also pilot test the communal purchase business model, start the branding campaign, and really enhance that mass demo like Adam was mentioning, and push that brand awareness from during manufacturing all the way through the product launch itself. So I think I can speak for all of us that we would be really proud and really ecstatic when we do see the planters really out there in Ethiopia and really improving lives. So with that, we really appreciate this opportunity to work on this project from the IDEO team and also from EDI as well. And to really round out your experience, when we're downstairs, we're going to be serving you a little national food that is made with teff for you to really sample and really experience what teff is like and how delicious it really is. So with that, thank you.
Awesome. Thank you so much, TEF team, and thank you everyone here for paying attention. We really appreciate it. Also, I would like to say thank you for all of the support. I'm sure each one of you in some way has supported these students in creating really beautiful, beautifully designed thesis projects. So